Welcome to week 8 of distance learning. This week we're going to focus on the ratio of corresponding sides of similar shapes and how they are proportional. Before we start on proportionality, let's review what it means when figures are similar to each other. We know that when two figures are congruent, that means that they are the same size and the same shape. However, when figures are similar, that means that they have the same shape but not necessarily the same size. And we can see that because triangle A, B, and C looks very similar to P, Q, and R, but triangle PQ and R is just smaller than triangle ABC. Similar figures have proportional relationships. We know this, so we can use that as a rule, and sometimes you just have to decide which sides of the first figure correspond or match up to the sides of the second figure. So for triangles ABC and PQR, we can see that line segment AB corresponds to line segment PQ because of the colored angle symbols in the corners. So we start from the blue arc and go to the double green arc, and that makes up the line segment AB. Just like over here on the second triangle, the single blue arc and the double green arc, if we start at the single blue and go to the double green, that is PQ. So that's how we know that line segment AB and line segment PQ are corresponding. Sometimes you will have to decide on your own without the help of any symbols, but a lot of times there will be angle marks in the corners of the triangle or a square in the corner of a square to show that it's a 90-degree angle. So those things will help you. If you have the measurement of some of the sides of similar triangles, then you can determine some of the missing sides of the triangles. So we know that these two triangles, triangles A, B, C, and triangle D, E, F, are similar. The reason we know this is because we see here that we have a single arc in the corner by angle A, and we have a single arc in the corner by angle D. We also have a double arc in the corner by angle C and a double arc in the corner by angle F. So what that means is that these angles, angles A and angle D, correspond to each other. Angle C and angle F correspond to each other. And by default, angle B and angle E have to correspond to each other because the other two angles match up. Once we know that the angles are equal to each other and they correspond, that means that these are similar triangles, and if they are similar triangles, they are going to be proportional. AB is proportional to DE, BC is proportional to EF, and CA is proportional to FD. So if we have a missing part, for example, we have the letter X variable here on the side of the line segment DF, we want to know what the length of DF would be if AC is 21, BC is 24, and EF is 16. So you can make a ratio or a proportion of the sides that you're given. So you match up the corresponding sides. So we know that BC corresponds with EF. So that's why we have the ratio here, BC and EF. And that is going to be the same ratio as CA and FD. So if these two sides match up, the ratio of those two sides will match up to, or be equal to, the ratio of these two sides. So we set that up, BC over EF equals CA over FD. And then we just plug in the numbers. What is BC? What is the length of BC? BC is 24, so we put 24 in the top. EF in the denominator here, oops, I don't know what I did there. EF in the denominator is 16, so we put 16 in the denominator. CA is 21, so we put 21, and FD is X. Then we can cross multiply to set up an equation. 16 times 21, we cross multiply here. 16 times 21 equals 24 times X. Then we can solve this equation. First we simplify the left side. 16 times 21 equals 336. So then our equation would look like 336 equals 24x. Then we divide both sides by 24. And when we do that, we get x equals 14. So that means that the line segment FD is equal to 14. And again, we figured this out just by matching up the corresponding parts in a ratio, matching up these two corresponding parts, these two line segments, even though one of them is a variable, and then we can cross multiply to determine the missing side. Similarly, when a figure is dilated, that just means that we have an original image and a change was made to it, making it either bigger or smaller. So when a figure is dilated, it keeps the same shape, but it changes by enlarging or reducing size. You can find the corresponding sides of these figures because they use the same letters for both figures. So in this example, we have A, B, C, D, quadrilateral, and the second quadrilateral is A prime, B prime, C prime, D prime. We always start with the pre-image, and we know that that's the one that doesn't have the prime mark beside the letters. Figure ABCD dilated to A prime, B prime, C prime, D prime. The figure got bigger, so this is an enlargement. The corresponding sides of the two figures show a proportion. For example, AB and A prime, B prime both have a measurement, so we can figure out how many times bigger the second image is than the first image. We always put, or we can see that AB is equal to 1, A prime, B prime is equal to 2, set these up as a ratio to show the proportion, and when you're working with dilations, you always put new over old. So the new line segment is 2, the old one is 1, and we know that 2 divided by 1 is equal to 2. So that is the proportion. That just means that the second image is 2 times bigger than the first image. Every part of the second image is 2 times bigger than the corresponding part on the original image or the pre-image. When you're dealing with dilation, this proportion is called the scale factor. On a side note, when the scale factor is bigger than 1, like it is right here, we found that everything was multiplied by 2, so 2 is bigger than 1, and that means it's an enlargement. So if you ever see that the scale factor is 2 or 5 or 7, anything bigger than 1, that means that it is an enlargement. On this example, we can see that the pre-image is ABCD, and again we know that because it does not have any primes beside any of the letters. The figure ABCD dilated to A prime, B prime, C prime, D prime, and we can see that the figure got smaller. So this is called a reduction. The corresponding sides of the two figures show a proportion. So for example, we can take line segment AB, that corresponds with A prime, B prime, and we can set up these in a ratio to show the proportion. And again, since this is a dilation, we always do new over old, so we're going to put 5 over 10. So down here we put 5 over 10, and we know that that reduces to 1/2. So that means that the proportion is 1/2, and it's also called the scale factor, is 1/2. And what that means is every part of this original image was multiplied by 1/2 to get the corresponding side of the new image. Once you know the scale factor, you can use it to determine a missing side. For example, we have line segment AD on the original image is 8. If we want to know what that would shrink down to on the new image, we would look at A prime, D prime, and we have the X here. We could set up the proportions like we did in the example a couple slides ago, or we can just say, okay, well, to get from 10 to 5, I had to multiply it by 1/2, which is the same thing as dividing by 2. So I'm going to do the same thing for these two line segments. To go from 8, what do I have to multiply it by to get to, or I have to multiply it by 1/2 to get X. So 8 times 1/2 is 4. So we would know that X would equal 4, or the line segment AD would equal 4. Just a little fun fact here, if an image is dilated by a scale factor of 1, it would stay the exact same size. And that makes sense because if you take this original image, you take one of this, let's say this line segment right here, and we multiply it by 1, we're going to get the exact same thing for the length of the new one. So a scale factor of 1 would result in a second image with the line segments all being the same size. Okay, so a few points to remember. Corresponding parts of similar triangles are proportional. Number 2, make a ratio of given corresponding parts to find the missing parts. Number 3, when dilating a figure, the scale factor is the proportion. Number 4, a scale factor of 1 would result in a new image being identical to the pre-image. Number 5, a scale factor greater than 1 would result in a larger image than a pre-image, and again, that's called an enlargement. And number 6, a scale factor less than 1 would result in a smaller image than the pre-image, and that is called a reduction.